Thank you for coming. Today, Tom Harvey will present you how build a Terraform provider and some cool stuff like this. Tom is engineer in HashiCorp. Now he's living in Berlin and like to travel. And it's love to speak, love to teach another guys and folks how create cool stuff. Welcome.
Cool. Hello. Awesome. So yeah, hi, I'm Tom. Thanks for coming. Thanks for setting all this up. So this talk is called Building a Terraform Provider. Who's using Terraform? Just by show of hands. Okay, cool. There are precisely 2 slides to this, which is building the title, and hi, I'm Tom. I work on Terraform on Azure. The rest of this is all live code. So what I mean by building a Terraform provider is that we're going to go from nothing to building a Terraform resource in code that will provision a resource. I'm using Azure just because it's what I use day to day, but the principles are the same for any Terraform provider that we create. So without any further ado, let's get rid of that. So I spent a little bit of time trying to find a small resource that we can do in a fairly short period of time. The one that I found a little while ago was Azure Machine Learning. Now, I've never used this service, so we'll find out. But I kind of want to walk you through the process of how we build a new resource. So let me boost that up. So this is a feature request that came in June. For Azure Machine Learning. And essentially what that is to go to the portal. Come on, there we go. And I've created one earlier. And what it does is spins up a machine learning platform, which pulls Docker containers and does some other things. So what we're going to do is to wrap this in Terraform. So to test this out, what I've done is just come in here, create one manually. It takes a few minutes, that's why I've done it ahead of time, but it's there ready. So yeah. So the Terraform providers are all written in Go. If we go to the code base, they're all open source, they're all on GitHub, so you can pull them as you need to. In this case, I have it cloned locally because I work on it day to day. And I'm just going to pull the latest master just to make sure we're up to date. Cool. And I'm going to use JetBrains Golang just because it's really handy, but you can use any editor you want. So yeah. So I guess there's several parts, which is within Terraform, we communicate with Azure using the Azure SDK. And that's available on GitHub as well. As here. And if we dig in, there is a machine learning service. Where are we? Machine learning. And then there's the API version that we can use. So let's take this one. And then this is the SDK. And so the SDK exposes several things you'd expect. In this case, we're going to create a machine learning workspace, which is like the top level thing. And then it has elements within it. So there's several bits of this we care about, which is creating a client, which just returns a class essentially. And then there's helper methods for us. So create or update, which will create it or update it. There's a get, which will retrieve it, and there's a delete, which will delete it. So yeah. So how do we use this in Terraform? So the first thing we need to do is to introduce this SDK inside of Terraform. And the way we do that, if we go to, let's start here. But let's not start there. Let's start in here. So inside of the Azure provider, if we go to clients and then client.go, this is like the base class where all of the Azure clients are available to us. And so what we're going to do here is, what is this, machine learning? Oop. Which we're going to, come on. Which we're going to do is machine learning dot client. And then we create a package, like a namespace, inside of the repo where we contain the clients. There's a reason for this. We're going to be moving some stuff later on, but we're just in a kind of transitory state at the moment. Sorry. So I want to right-click new directory, and then we're going to create a client. Now, there's several bits to this. I'm going to copy and paste this one because it's here. So there's two things we care about. The first is naming the client itself. So we're going to use this client from the SDK, which is the workspaces client. So we're just going to do workspaces client, which is then a pointer to machine learning services, learning. And then we're going to look for a workspaces client. This is a little bit hard to do because of the screen resolution, but I'm gonna select the version, the 2019 11.01 version. And what Go is going to do, or it'll make that available to us. And then we're going to use the workspaces client here too. So let's do workspaces client. There's a little bit of groundwork to get this up and running, then we're good. Workspaces client. So the reason there's two ways to build up a workspaces client. The first is to use just the default URL, and then the other is to use like a custom URL. And what this allows us to do is to support both Azure Public and Azure Stack and Azure Germany and Azure Government and China and whatever else. And this takes two things. This takes the base URI, which is available here, and it takes the current subscription ID. So if we thread those two through, and then we're going to configure it with whatever authorization it needs. So in this case, an access token for the Azure APIs, and then just return that here. So workspaces. Now we need this up as a pointer because in Go, if you don't make it a pointer and you don't define it, it'll get a default object. So this just means if I try and access it without having to find it here, it'll throw an error, or it'll be a nil pointer. So cool. At which point that's hooked up. So that's kind of the basics. So at this point, we've not done a lot. All we've done is use the client. So now that we've defined it, I guess we should check out a new branch, actually. Machine learning workspace. So yeah, so far we've created two files, the client and the machine learning. So the next thing we need to do is to vendor the source code. Now the way that Go's vendoring thing works is that you first import it, and then you ask Go to download the dependencies. So mod vendor. The way to do this is with Go mod vendor. My environment's a little bit different, so I have the environment variable, but just trust me, that works. And if we do a get status, what it's done is several things. It's downloaded if we look at the get diff vendor modules, what it's done is worked out, because we've imported it, that we're going to use this SDK. And what it's also done is to check, commit a copy of the SDK in the vendor folder. So we can go, when you ship a binary or you ship a program, we commit the dependencies inside of the vendor folder. So at this point, this should work. In fact, there's one more thing we have to do. Spoke too soon. Yeah, so we've defined the machine learning client here. This is just if we have multiple clients, which we're going to. So the final thing to do is to hook it up at the top level. So here, this is just client.machine learning equals machine learning build client. I appreciate this is spread out a little bit. We're moving some things around, so it's not super clear right now, but that's all of the hard bit done. So yeah, so at this point we've built the client, it's usable. So how do we go building a Terraform resource? Well, so if we take a look at a resource group, for example, the way that we name the files in here is just resource just for historical reasons, and then the name of a thing. So in this case, this is a resource group. And a resourcing in Terraform has 4 functions that we care about, or 3. Update is optional. So you have a create, read, and delete. And then there's some other stuff below. In the sake of time, I'm going to copy paste this, and we'll go through it as I fix it. So we're going to create a new file, resource arm, machine learning workspace. Dump that in. Okay. So there's 4 functions here. The first one is the actual resource itself. So I'm just going to rename that. And I'm going to do the same for these. I can't define them. Yeah. Bear with me 1 second. Cool. Okay. So yes, to come back to these. So there are 3 methods that we care about, which is the create, which in Azure, the APIs are upserts. So you saw in the SDK earlier, the SDK method is create or update. And so we share in Azure the create and update method just for convenience. Just to update those. Okay. The next thing is this import thing. This allows Terraform to do import. We're going to ignore that for now, but you basically just need to add that line and everything works. The next thing is timeout. So this is something that we're supporting shortly, which is why it's here. And then there's the actual schema itself. So what this means is that when you define a resource in Terraform, by default, if you have no fields in here, all you can do is resource, Azure RM, resource group, whatever, but no fields. So what these are is a mapping to the fields that are available inside of Terraform, inside of the Terraform config, sorry. So here, for example, name equals whatever and location, etc. So yeah. So let's go to the one I created earlier. Cool. This portal's more fun on a big screen. Okay. If we go to export template, what this is going to do is give us the actual ARM template as deployed. And so we can see here there's several things that we care about. So there's the SKU, there's the location, there's the name. Sorry, I can zoom in. There's the name, location, SKU. There's some identity, which we're going to omit for now because let's just ignore it. And then there's some properties. So it looks like some of these are settable, so the storage account, the key vault and the application insights, and some are retrievable, like read-only, like this discovery URL. And so what that means, Azure has this wonderful website called resources.azure.com, if anyone's seen it. And this allows you to see the Azure API. So the way it works, just going to copy URL just to fast track this. The way it works is that you scroll through the sidebar and say subscriptions, the subscription you're in, etc. I'm going to cheat because I haven't got all day. You can paste in the resource ID in the URL and it takes you straight there. Okay. Oh, interesting, it's not in here. Well, that's a first. Cool. Okay, I guess we're doing this the old-fashioned way. So yes, so there's several fields we need to support. Name and location are the first two. So let's go ahead with that. There's also the SKU. So in this case, let's take basic. So let's add SKU in. And there's several options to Terraform fields. So the first one is several fields that can be set. The first is type. So in this case, I'm going to go with a type string because it's a SKU. And we're going to say it's required. It might not be, we'll find out later. The other options that we need is the storage account, the Kyiv, and application insights. So bear with me 2 seconds. So storage account, probably name. Application insights name, and Kyiv name. Okay, cool. Yeah, so let's go through this. So for the sake of simplicity, I'm going to remove that. Okay. So what the create function does essentially is to create an object and then pass that to your API and say, please create this, and then retrieve it, get the ID, and then that's it. So in this case, we're going to read some values out of the configuration that users provide. So in this case, the SKU and some other fields. So the first thing we should do here, if we go to machine learning, we're going to set the client we want to use as the workspaces client. We can then come here and go create or update. And if we dig into this, this is the same code that we had in the website, on the website. But this takes an object. And this workspace object has the things we saw in the portal. So the name, identity, location, etc. And it also has this workspace properties. And it looks like there's a bunch of different fields that we can set or read. If they're read-only, it has read-only marked on them. Okay. But by reading this, it looks like this is the ID rather than the name. So we can pass in the ID of the key vault, of application insights, and of the storage account. So let's update those before we go any further. Storage account ID, application insights ID, and key vault ID. Okay. So the next thing to do is we are going to new up one of those objects. So this is a workspace, so we can do workspace equals machine learning services dot workspace. I think that one. Yes. Sorry, it's hard to do autocomplete on a screen that big. Okay, and this gives us an object. So for anyone unfamiliar, you define a variable in Go like so with a dot equals, and that says create this new object. If you just want to do an assignment, it's an equals, but it has to be assigned first. So that's what the dot means. Semicolon means. Okay. Next thing to do is to hook these fields up. So in this case, we're going to set up the name. So this takes a pointer to a string. And we have a little helper method here called utils.string. So let's just thread that through. So we have name, we have location, which I'll cover this in a moment. So utils.string, string location. We have SKU, which we'll come to. So this takes a pointer to workspace SKU. Machine learning services dot SKU, which takes a name. Which we're just going to define SKU in a minute, and it takes a tier. Feel free to reach out. Feel free to ask questions. By the way, I realize I'm talking and typing, so cool. So two things of note here. The first is that we have this object D, and this thing here d.get. And so what this does is to read the Terraform configuration users have defined in code. And then make it available to us so we can retrieve these values inside of the code. So in this case, we retrieve the name, location tags. So for example, to get the SKU, it's then d.get SKU, and we're going to cast that to a string. And because we've defined that here, that'll work. If you haven't defined the field, it'll be nil. And so when you try and cast it, it'll error. Cool. And we can pass that in here. And that one's a pointer, doesn't it? I don't want some other fields. Okay, so this takes several values. So this takes the resource group, the workspace name, and the parameters. So we need to pass in resource group, the name, which is the workspace name, and then the workspace itself. And we can thread through the other properties in a minute. So tags is tags.expand T. There's some conventions here, so you'll find this in other resources. I'm just trying to go through the process of building it. Okay, so we need a resource group. So let's do that. Let's add that in here as well. So we can do d.get resource group name, and that's string. So we need to come up here and define that, and that's resource group name. And we have, because resource group is used in basically every resource, we have some helpers here. So there's schema resource group name. Okay, and that works. Should work. So let's pass the resource group into the get, just to make this work. Okay, and then we'll talk through this. So what this does, this creator update, it returns two parameters. It returns a workspace, which is the created workspace, and an error. And the error contains information like the HTTP status code, the result contains the status code and anything else. So we can say if there was a 500 error or a conflict or something, then do some actions on that. Okay. We're just going to make this error message a little bit more helpful here. So error creating machine learning workspace, and then put this in quotes, and then resource group also in quotes. Go's really particular about formatting strings missing, so it'll fail to compile if these aren't passed in, which is kind of nice. Okay. Okay. Cool. So this is a fun one. So the Azure API uses different cases for the IDs on different URLs. So what these are, this creator update, let's take preparer, it shells out to this URL, right? And the string formats it however it needs to. But it doesn't always mean this URL isn't necessarily the same for get as it is for create. There's several cases where it changes over time. And so what we care about is not necessarily the create URL, but the get URL. We'll come to why in a moment. But yes, we need to retrieve it to get the canonical URL essentially. Cool. Okay, and then we pass into read. So that's create done. Oh, there's some other properties. Sorry, I've forgotten about that. So let me just type those out. Machine learning web services dot properties. Okay. And this takes a string for application insights. Okay. What's the other ones we take here? So key vault was one, and the other one is storage account. Key vault ID. Okay. So we have the three basic fields here, and this, when it's submitted, will match ignoring identity because we don't really care, ignoring API version because we don't need it, or the type. That should match, and so we should be able to create one with this data. So the next thing to do, let's hook up the read, and then what we're going to do is go and apply this and actually see it working. So the read is very similar. What the read does is to look at the ID that exists, which is the resource ID in Terraform, pass that ID, so pass the URL in this case, and then pull some values out of it. So if we come here, we're going to use the workspaces client again, pass the ID, and we're going to get two things out of it. The first is the resource group, and the other, we're going to say from the path, I want to get particular segments. Now, to go back to the question from earlier, the Azure IDs in Azure are based on these URLs, and they're essentially key value pairs. Oops, sorry. They're essentially key value pairs. And so what we do is to take this URL, split it in pairs, and then have, for example, key value, key value. And so what we essentially do here is pass it, and we're going to pull out the resource group name and pull out the workspace name. So for example, resource group and name. And then what that does is we can then look up the workspace, pull it out, and then retrieve any information that we want. So for example, in this case, I'm just going to update the error message while I'm here. Workspace, queue, resource group, queue, so name, resource group, and that. All right. Now, at the moment, this only sets 3 fields because we copied and pasted from the other results, so we need to set some extras. So let's do that while we're here. So resource group name is then resource group above. We then want to set the other properties, and they were within a properties block. Now, because we can't guarantee the response from Azure will contain the properties block, if we look at the response object here, where are you? Get. Shows a workspace. Because the properties object here is a pointer, if the JSON returned from Azure is malformed, like invalid, this will be nil, and so we'll have a crash here. And so to protect against that, what we're going to do is just nil check that. And so we can do, Go has this nice helper for that, which is we can do if assign a variable if it's not nil. It's not nil. Cool. And then we can access the properties within that, and we can guarantee at this point that it's not nil. So for example, the storage account we care about. So let's set that value back for storage account ID. What was the other one? Application insights. And key vault. Okay. And delete, I'm going to just do very quickly. It's exactly the same. So in this case, machine learning workspaces, we pass the ID again. So I'm just going to pull that out because it's, there. We're then going to pass in the resource group and the name because those are arguments on this method call. And what that's going to do is delete the workspace. In this case, it deletes it straight away. And so we should be good. So we can ignore the first variable, that's fine. I guess maybe we do care about it for that. Fine. Okay. Cool. And so what we're going to say, if there's an error returned, and that error happens to be a not found, so if we've deleted it and it returns a not found, then that's fine, because we expect that because we're deleting it. So in this case, again, error deleting machine learning, workspace, queue. This is just to give users a more helpful error. You don't have to write this, it just helps. Okay, so this is a very basic Terraform result so far. So like this is the bare minimum fields. We could add more later on if we want, but this should be sufficient for now. So how do we actually hook this up? So this function itself is called, and if there's a file called provider.go. And what this does is it defines, to come through here, all of the data sources that this provider supports, and then all of the resources that it supports, and then way further down, all of the possible values that can be set in the provider block. So in this case, the subscription ID, the client ID, the tenant ID, whatever you need to connect. Sorry. In Azure, these are, we pick them up from the environment if you don't configure them in line. But yeah. So what we need to do, we've created a resource here. And so this is basically just a map. So we can define this as Azure RM, machine learning, workspace. And I'm going to try and put that in the right place because, yeah, where are we? Machine. Yeah, okay. I have a linter set up, so whenever I save it, lints it, because, yeah, cool. So that should work right now. So this is Go, so you can do Go install, it'll install it. We have a little helper script that checks some things first. So we use make, so we can just run make. And then it installs it. Okay. Yes. We're just going to test this by hand just to prove it works first. Mostly so I can work out the configuration we need to write the test. Cool. So. All right. Machine learning workspace. Okay. I'm not going to use Vim because, yeah. Cool. So let's make a new file, main.tf. Okay. Now, if we look at the schema that we defined, there's 3 things we care about here. Well, there's several things we care about, actually. The first is it needs a resource group. So let's define that here. Azure resource group, which takes a name. So Tom demo, location is an Azure region. So in this case, West Europe. This then takes some other things. So let's start scaffolding this out. So we can do machine learning, workspace, test. Okay. So this takes the name, which we're just going to spin one up here. So Tom Hug ML. It takes a resource group name, which we're going to thread through from Azure own resource group .test.name. It takes, does it need a location? It does need a location. So we're going to do the same thing here. And then we need a SKU, which from the portal was basic. It takes a storage account ID, which we'll pull up in a minute. Takes an application insights ID, which will also take in a minute, and a key vault ID. Okay. So we need a storage account. Now, I can never remember the code for this, so let's come here, copy, paste. Cool, I'll move a storage account. And so we can thread that through. So storage account ID is just your storage account.test.id. Same for application insights. Come here, borrow that. Tom Hug SA. There's a limitation on storage account in the naming, so just trust me on that one. Tom Hug. Cool. Let's thread these 2 through the same. Cool, that works. And then we can thread through application insights. Oop. And then finally, key vault. This one's a pain, just because of the way key vaults are built. But don't need tags. I'm going to ignore that. No, you need that. And that has to come from client config. So for a key vault, you need to pass in 2 values here. Because I have the code base open in front of me, I'm going to pull them from the key vault tests. Because, yes. And we'll come through tests in a moment. Come on. Where are you? So we can pull these values from a data source. So in this case, the client config. So I'm just going to copy and paste that. Who doesn't love a good copy and paste? Cool. And we're going to bring them in. Okay. So at this point, we should have all the basics created. So all the dependencies created, sorry. Keyvault.test.id. Now, just for the sake of, in fact, no, you know what, let's go through and do this. Just make sure the key vault has a unique name because these need to be unique in Azure. Tom key vault. Okay. So I've compiled this locally and we've written a test Terraform configuration. Now, because I'm compiling this locally, I've also, so Go itself has a Go bin folder, and this is where it stores all the binaries that you've compiled to the system level, which is what we're doing with Terraform. You can also do go build dot, and it'll just compile it locally, but we don't want to do that for various reasons. What's important, why I'm calling this out, is I've got Terraform and the provider side by side. And so what it means is if I, for example, in this Terraform configuration, I've not defined any provider block. And so what Terraform would normally do in a situation is to go and download the latest version available on the releases website and bring it in. But because I have this set up locally, what it's going to do is say, this Terraform binary sat here, so I'm going to use that one unless you tell me not to. So what we should be able to do is run Terraform init. And if we do Terraform version, let's ignore that. If I run Terraform providers, you can see it's unversioned. There's no version set here. And so this should work because this is using our code. Bear with me 1 second. Okay. So if I run Terraform Apply, I'm just setting up some secrets locally. If I run Terraform Apply, what this is going to do is then go and create those resources for us. Full disclaimer, I don't know how long this takes for the machine learning workspace. So we'll find out. Cool. So it looks like it should work. Let's like, yes. But to the point of whoever asked the question over here, the reason we do this manually once is to get the minimum Terraform configuration we need, just so we can check it works, then we'll write some tests afterwards. If you know the configuration up front, you can do that as well, but yeah. Cool. G'day. Okay. So why did that fail? Oh. Sorry, key vaults are painful. So if we rerun Terraform Apply, it's going to pick up, we've created everything but the key vault and the workspace, the machine learning workspace. So we can then go yes. And it'll create the key vault and then pass that in. Okay. Tom, Kyiv, hug. These need to be globally unique and within 16 characters, so let's just hope that works. Yeah, it's probably fine. Okay. Cool, so it's creating the key vault. And if we go to the portal while this is running, we should be able to see these here. So resource group, not that. That one, yeah. Tom, dev, hug. Okay, so we have the resource group here. We have the application insight storage account key vault, which makes sense. We wait for this to finish. Yeah. For Azure. So they, we don't have a shared account for that. However, Microsoft have a trial. So you can use the credit on that to do it, and then we can run the test for you. All the resources are there. Yeah, yeah. There's, I think you get $200 in credit a month or something. I forget, yeah. You get $200 credit. Or if you have a work account, like I used to do this on my work account before I joined HashiCorp. But yeah, what we'll do is we'll run the test for you when you send a pull request as well, because we know there are some resources that either take ages or cost a lot, which isn't ideal, but we do what we can. Yeah, we'll do it anyway, even if you don't ask us. Cool. So what happened? So this is when Go errors, it panics, which is cool. So let's take a look. So this is failing on line 75. And what it's saying is I couldn't convert a nil object to a string interface, which, all right. So what's line 75? Excellent. Cool. So in this case, I'm doing d.get. I mentioned earlier, if you don't have it defined in the schema and you try and do d.get on it, it'll panic or error. So in this case, that's exactly what's happened here. So if we just go ahead and define tags as tags.schema, recompile, give it a second. So it's slow when you're watching it. Come on. Cool. And so if we go and rerun that, this time it hopefully works. So this time we're only creating the workspace. Cool. Make sure to create your workspace using client which supports MSI. Okay, so what this is saying is that we need to pass in the identity block too. So let's do that. Ordinarily, I would make this user configurable, but in the interest of time, I'm not going to do that straight away. So for those who don't know, a system assigned identity in Azure basically says create an account that I can use, the service can use automatically and just give me access to that. As I say, ordinarily I would hook it up in the configuration, but for the sake of simplicity, that's not for now. So if we rerun that, so the other reason we spin this up locally, oh, fun, okay. Okay. So this new API version has some different requirements. So what I'm going to do is in Bluetooth fashion, which I'm pretty sure isn't a thing here. We're going to use one I made earlier, so an older version, which I wouldn't normally suggest, but it'll get us around this problem. So I'm going to switch out for an older API version. Ooh. Just going to pull that API version down, and we'll switch to that. Cool. Now if we compile, just want to check everything is there. Okay. So for an older version, you can't set the SKU. Makes sense. And maybe we don't need identity. Let's find out. Come on. So it goes really demanding that if you define a field, that you use it. So in this case, where I'm not setting SKU anymore, that's fine. It's complaining when compiling that I've defined a variable but not used it. Come on. Okay. So again, let's try again. Okay, and because we've removed the SKU argument, it's saying that's no longer valid, which is fair enough. So let's remove SKU, and again. Takes a little while to get the first one set up, and then you're good. Come on. What are you doing? Okay. Is this to do with the client I'm using? That's fun. Okay. 2 seconds. If I switch to a different account, it's be really annoying if it doesn't work. Cool. Bear with me 2 seconds, sorry. Because I've switched from using a service principal to using my account, it's some weirdness. Ooh, not that. Okay. Hopefully this time. If not, we're going to fake it and move on because I want to show you the rest of it. Okay, so we are going to do something I wouldn't normally recommend. We're going to assume it worked. And I'm going to use the one I created earlier by hand. Come on. Come here, machine learning service. So we're going to assume it created successfully, which I wouldn't normally do. But I don't really have much other choice right now. We're just going to do d.setID to the actual ID that we've got, the one I created previously. So, okay, Yeah. Okay. So if I come in here and run Terraform Apply, that will create it and then go and read it. I appreciate this isn't ideal, but working with an API that I haven't used before here. Cool. Cool. Okay. This is fun. You know what? I'm going to walk you through with an existing resource, and we're just going to run with that because, yeah. Let's take a network. Let's take a resource group because it's easy, like really small. Yeah. Okay. So yeah, through the read method, let's assume we've created the resource group. Let's set up a new one just for the sake of it. RG. Sorry about this. Sure, resource group. Test. Name equals Tom, please work. I guarantee this one will work. Cool. So we can run Terraform in it. We can run Terraform Apply. Always exciting. Yeah, so just to recap on the resource group, this supports three things. This supports the name, location, and tags. And so what we do in here is set those three fields, a name, location, and tags. Location is special in Azure because it can either be defined as West Europe or what's the other one? Yeah, like West Europe, one word. So we just normalize it down to a lowercase string. It just means we get no diffs on things. Cool. So in this case, we're creating a resource group. Hopefully this works. Cool. And it said created. Awesome. Fifth time lucky. Cool. So yeah, what happens if we introduce a new field here? This is a resource group. That's going to be really hard. Let's go through a test. So we know the resource works. So if we go to the test file, I am going to comment most of this out. And I'm going to start with this one. Cool. So a resource group. There's several parts to creating a test in Terraform. What we do is actually spin up Terraform configuration. So like the code we saw earlier that we wrote out in Atom, we basically provision that and then make assertions on it. So for example, we'll provision the resource group, then check it exists, then destroy it, and then check we've destroyed it. So in this case, this is doing several things. Just to fix up the imports. Sure, why not? So we use a regular Terraform configuration, but we pass in a random integer and the test location, which is just an environment variable, just we use everywhere. So in this case, we're going to pass in the integer and the location string, and we're going to return a string. And this is what this is going to do is return some templated Terraform configuration that we can use to check our test works. So we're just going to do format string. It's just the way you do it in Go. So we're going to do resource Azure resource group test. Then takes a name, which is then going to be we have a convention internally. So we're going to make that act test RG, and then the number that we pass in, and then location, which is then we can pass in two. So rint and location, and we have a formatted Terraform configuration. The reason to do this is if we spin up, we run 2,000 or so tests a night in parallel, and so using the same name would break things. So hence the unique IDs here. Cool. Every night. For every cloud, it's fun. So yeah, so this is a test in Go. As I mentioned, we spin up the configuration, then we check it exists, which is the next method to implement. Because I suck at writing these, I'm gonna just, thanks, pull that up. So to walk you through this bit, right, what this does, we provision it with Terraform. And then Terraform stores the information about the resources created in its state file. And so what we do is to pull information out of the state file that's been created. So we could pull out the name field, location, or the ID and do whatever we need to with it. And then we look it up using the client, using the Azure SDK client. And we basically check that, so this method checks it exists. So if we get a 404, then it's like, it should fail. Otherwise, it returns no error and it passes. The other one is the destroy. Which again, I'm just gonna do rather than retyping, because yeah. Cool. And what this does is to check that when we've deleted it, so, sorry, to go through that test, we basically first provision it, check it exists, then we do an import, which we'll cover in a minute, and then tear it down. And so at the end of this step here, we run Terraform destroy, essentially. And then when it's all done, we then confirm it's actually gone. So this method itself loops over all the resources in the state file, if there's any left over, looks for one called Azure resource group, gets its identifier, and then passes that in. That's actually a bug. Cool. That's exciting. Good to know. Yeah, so that's actually a bug. So in the case that it still exists, we'll return an error. But that's it. So I'm going to take this test name and to explain how this works. No, these are in the repo, sorry. In the Terraform repository itself, in the README file, we have a section down here on how to run the tests. And you can do this by doing make act test and then this string. And this is basically a prefix on the test that should be run. So if you have multiple, it'll run them all in parallel. And you need some environment variables set for it. Now, because I do this a lot, I have a little helper to do that, but it's all just running. So if we go and run this test, all that's going to go do is spin up that Terraform resource in Azure, provision it, check it exists, and then destroy it. It doesn't destroy it before the input. Yes, I should go through that. Sorry. Let's go through it while it's running. So what import does, when you provision something in Terraform, so here, we have this state file that keeps track of what I provisioned. Wrong folder, sorry. We have this state file that keeps track of what I provisioned. For import, what we do is take the ID, we delete this resource from here, and say Terraform import the resource group like you would on the command line with the ID. And then what we do is check the fields that are defined here match the fields that are defined in the Terraform configuration here. And so we basically confirm that every field that's defined in the code is actually set in the provider. So that means if we, for instance, forgotten to set SKU, it'll pop up and show us that we've forgotten to set SKU, or whatever it is. Mm-hmm. We do it before we destroy it. Yeah. We used to do these as separate ones. Then we realized it was kind of pointless. We might as well just chuck it in the same test. Cool. And 70 seconds later, it's provisioned a resource group, checked it exists, destroyed, like imported it, then destroyed it, and then checked it's gone. And that's all done. Parson, what, sorry? Here. So because we're running them in parallel, so my little helper here runs go test, which is what that does essentially, with a couple of things, because I want them to run sequentially for certain reasons. So what that's saying, when it's popping up here as pause and continue, is it go when it runs a test, runs 5 tests in parallel, like runs all of them in parallel, pauses the process immediately, and then runs them in batches of 5. Just the way the go test runner works. Because I'm only running one, it's only running one test here. If there were 5 tests in the file, it would show, and I asked it to run all 5, it would show 5 and then just run one at a time. Yeah, it's just the way Go's test framework works. Yeah, cool, so that works. So what happens if we want to update this? So the field's name and location can't be updated. But let's say we can add some tags in here. So let's add one with tags. This is going to be exactly the same, except it's going to say, hello, Kyiv. That is the right spelling of Kyiv, right? Cool. It changed recently, right? Yeah, cool. Wasn't imagining things. Sorry. So, excellent. So we're going to spin up a second test. So this basic one literally just provisions it, checks it works, tears it down. We're going to create another one called an update test. Copy paste again. And what this is going to do is provision 2 Terraform configurations. First, it's going to provision the exact same one we made earlier, so the basic test with just the name and the location. Then what we're going to do is say in a second step, what I want you to do, let's ditch the import for this one. We're then going to say provision 1 with tags, test location. And afterwards, we're then going to just verify it still exists. And maybe you want to check some values on it. So for example, for tags, if we go to state file, we can see here that tags is an empty array. So what we can do is check that field specifically if we wanted to. And there's a test function, test check, set, or test check, sorry, which takes the name of the resource, which is above, to look up, takes the field, so tags, so I think it's a dot. And then we want to confirm there's 1 tag in there. And we could also confirm that it's Kyiv. And same here, if I wanted to check each individual property, you can define it like this. The reason we have the import test is it means you don't have to write hundreds of these. You just write an import test and it works, which is much easier. So yeah, what that does is provision the first one, check it matches, provision the second one, check it matches, and then destroys it all. And because these are the same resource, the only difference here is the tags, what it's going to do is update that. So if we go and run that single test, this will be probably a minute and a half. Just waiting for Go to compile, do its thing. And then eventually, there we go. So it's kicking off the update test. Any questions while that's running? Hey. So in this case, tags as a map, I believe. Yeah, it's a map. Yep. Correct. The default one is quite hard. You can do it in two ways. The way that we do it, honestly, is to provision one by hand, get the hash, and then use it. If you're using the built-in hash function, if you're using custom hash function, you can call out to that and then build up however you need to. But the other thing you can do, where I'm doing this assertion here, for a map, that will be tags.pound or hash. So you can check them that way. What I would strongly recommend is not doing either of those, just use an import and life will be way easier. Yeah. Import tests were basically all of the, like, less code, and it's much easier for you. Much, much easier. Cool. That's updated. So, yeah. Sorry, it took a while. Cool. And then the final part is hooking up the website. So there's two bits to this. There's a sidebar, which isn't particularly exciting, but we just add a link in here. And then write some documentation. So we have folders in here for data source and resource. This already exists for a resource group, so there's not much point in me retyping it, but essentially what this is some markdown for us internally for which subcategory it should be in for some stuff coming in the future, the title of the page, what sidebar should be active, etc. And then the actual content itself, which is all marked down. So in this case, a description, an example usage, and here's all the arguments that are available. But yeah, that's basically it. It's annoying. The original resource I was trying to do didn't work, so apologies about that. But yeah, then when this is rendered on the website, where are you? Here. If we go to base resources, then resource group, it comes out like that. So that's like the whole creating a resource workflow, which is kind of cool. So the only difference for a data source, if we go to resource group, there's 4 functions up the top I mentioned earlier. The sole difference between a resource group, between a resource and a data source, sorry, is that a resource has create, update, and delete, and import and some other stuff. A data source literally just has a read function. So if we come here, data source, resource group, is exactly the same as the other one. The timeouts are different for reasons. But the fields are here. Yeah, we basically look the information up, retrieve it, and then in this case, just set some values. So we pass through to the other read function. So get the ID, get the name, the location of the tags. And that's it. Yeah, any questions? Cool. Well, yeah, that's creating a Terraform resource. It's the same for any provider. Azure has some specifics here. So in particular, the IDs, where they are segments, is very Azure specific. Amazon has like short identifiers. Google has something different. But fundamentally, this is the same if you work on the Azure provider or on Google or on whatever else, or on any internal providers too. So yeah, with that, thanks. That's it.
Thanks, Tom. Any questions? No? Okay, thanks for coming.
Thanks.
Oh, okay. And maybe if you'd like stickers, you can grab any of this. And also we will have screencast of this beautiful presentation. So if you something not understand, you can ask Tom now or see it later. Thanks for coming.
Cool. Thanks a lot.